So let's make several examples to see how the power series will work. Okay. The first one will be the simple one, use the standard power series form. Okay. The standard power series solution. Okay. The example is 1 minus x squared y double prime minus 2xy plus 2y equals to 0. And in order to solve the second order linear ODE with variable coefficients, we first step is rewrite this ODE to have the highest differential term coefficients to be 1. And here, this is the second order ODE. So the highest differential term is y double prime. Make the y double prime coefficient to be 1. So that is y double prime minus 2x over 1 minus x squared plus 2 over 1 minus x squared y. That is equals to 0. So this is 2xy prime, 2xy prime. That is equals to 0. Okay? Then let's see at x equals to x naught. When x naught equals to 0, the coefficient two x over 1 minus x squared, 2 over 1 minus x squared, this is the px, this is the qx, okay, are both analytic. Okay, are both analytic, then we can solve using the standard format. If they are not analytic, then we will trying to see how the Fabness method work. If even the Fabness is not working, then we couldn't solve these equations. Okay, so we have the second step. There we want to write our standard power series format, then write the y prime, y double prime. So we have the standard format yx equals to the sum from m equals to 0 to infinity am x to the m's power. This is the standard format with the x naught equals to 0. Okay, the center is 0. Then we have y prime x equals to m from 0 to infinity m am x to the m minus 1 power. Y double prime is equals to sum from m equals to 0 to infinity m times m minus 1 am x to the m minus 2 power. Then the third step, after we write our y prime, y double prime using the power series, what we need to do is substitute the y double prime, and y prime into the original format, which is the original ODE, and trying to see what is all the term look like. Okay, so put y double prime, y with power series form into the original ODEs. Okay, so let's see how this works. We have basically y double prime minus x squared y prime, y double prime minus 2x y prime plus 2y equals to 0. Then we have m from 0 to infinity, m times m minus 1, am x to the m minus 2. That is the y double prime minus x squared times y double prime, which will be similar to the first term, am x to the m. Here is now x to the m minus 2 because you already times x squared for the y double prime. So it's going to be x to the m term. Then minus 2x times y prime. So the x times x to the m minus 1 term will be x to the m term. So that will be minus 2 from 0 to infinity m a m x to the m term. And that is final plus the y term there, which is from 0 to infinity a m x to the m, that is equals to 0. So this is the format after I put the y double prime, y prime, y with the power series form into the original ODEs, and we get this equations which have x to the m minus 2 term, x to the m's power. Okay, and you can see that this term, the power order are different. This is m minus 2, this is m. Then the first step, we are trying to put all the standard powers to be from